Alright, so now with that little tangent aside, now we can get back to looking at the other problems. How are we supposed to handle a subtraction problem? What's up with that? Well, first of all, let's get our two vectors that we're going to need here. So let's just focus in and work with nothing but vectors m and n. So now vector m's components are 5, -7 once again. And now vector n's components is 0 and 4. But now this time what they want us to do is they want us to subtract them, right? So here's how you handle a subtraction problem. With the subtraction here, you're going to want to take that negative here and work it just like a scalar. For example, right down here you take vector p and multiply everything by 7. Well, this time we're going to multiply both these two components here. We're going to multiply everything by a -1. So it's kind of like distributing that negative sign and putting it in for both of those. So we're going to subtract each one of those. So either move the negative in there and make an addition problem, or we can just leave it like this and just do it mentally. 5 minus 0 gives us 5, and then -7 minus +4 would give us -11. So there would be our horizontal and vertical components right there for our resultant vector. And just to backpedal here for a brief minute, like I said before, if you wanted to move that negative sign in there and do one of these kind of numbers, where now you've moved the negative inside with the component form here, it's very, very critical that you now change that negative to a positive here, and you get the result by rocking and rolling here. And 5 plus -0, there's no such thing as that, so you're just going to end up with 5. And then -7 plus a -4 would still give you -11. So it doesn't matter which way you do it. I just prefer to do it the mental way and not writing the negatives in there. Because a lot of times when you write the negatives in there, some students tend to forget and they still treat it like a subtraction problem, and they end up crossing themselves up and getting a wrong answer in there. Just remember, it's a subtraction, right? So don't try and complicate it. You're just taking the number here, subtracting the number that was there. So -7 minus 4 gives you -11. Let's look at the other example here. Pretty simple example right down here, but let's go back and remind ourselves how much vector p was worth. Yes, vector p was worth, had a horizontal component -1 and a vertical component of +3. So what we're going to be doing here is just multiplying each one of those components by 7. Pretty straightforward. So now when you're attacking this, it's very much a relative or a sibling, a cousin, whatever part of the family tree you want to put in here of the distributive property. So that 7's going to move in there, and the 7's going to move in there, and we're going to multiply those together. Easy peasy. Now let's take a look at part D. Got a little bit of prep work here first. One thing to note about these problems here is you're not just working with vector m, you're not just working with vector n, and you're actually not even just working with vector p. What you're doing with all three of these things is just a little slight modifications of your original vectors here. They want you to double vector m, they want you to triple vector n, and they want you to use the opposite of vector p. So let's just jot down the original vectors first. Okay, so now what they want us to do with these ones here is modify each one. Now with the vector m, they just want us to double each one of those. Let's just go ahead and do that. Now we have 10 and -14. Moving on to vector n, they just want us to triple each one of those values. Simple, simple, simple. So now we have 0 and 12. Now with this one here, with minus sign out here with the vector p, if we were to distribute that in here, notice what we would get here in this case. We'd get a +1 and a -3. Now because we put the negative in there and that negative moved in here, that's going to make that a positive sign. That's still a positive sign no matter what. And so now we're just going to combine these together. Realize how we're going to properly attack this thing here is let's go ahead and combine all of the horizontal components together. 10 plus 0 plus +1, well, doesn't that make here a +11? And let's do the same thing with the vertical components. -14 plus 12 takes us to -2, and then -2 plus a negative 3, we're at negative 5. So there we go. So all these right here are those final answers that I'm looking for here when you're doing these operations.